Welcome to application 2A-5, focusing on literal equations. Our learning target today is that I can solve literal equations. So let's go ahead and jump into the application. You're going to need your application sheet out and we're going to look at problem number 2. And as I read through this, I'm just going to highlight my important information. So the formula F equals m times a is used to describe the relationship between force, mass, and acceleration. Now we're given that the units for force are kilograms times meters over seconds squared. Now mass is typically measured in kilograms. Based on this information, what are the units of acceleration? So we are asked to find the units for acceleration. We are given units for force and we are given units for kilograms. We're also given the formula F equals m times a. Now, we said we are trying to find acceleration. So we're going to use our literal equation skills to get that acceleration by itself. So we look at what's happening mathematically. We're multiplying a times m. So to undo that, we have to do the inverse of multiplication, which is division. So we need to divide both sides by m. So when we do this, we get F over m equals acceleration. Now notice we are asked to find the units for acceleration. We have acceleration all by itself now. Now, that gives us what a is equal to in the formula, but we're actually asked to go a little bit further than we've been doing in this practice and find the actual units. So that means we're going to have to plug in this information that it gives us here. So if I look at my information above, it tells me that force right here is measured in kilograms times meters per second squared. So I'm going to replace that F with kilograms times meters over seconds squared. Alright, now I am told that my mass is measured in kilograms. So where that m is, I'm going to replace that with kilograms. Now I still don't know what my acceleration is. That's what I'm trying to find. So right now we see that acceleration is equal to this giant mass right here. But what we can do is we can simplify this to be able to cancel some of our units out. Now notice we have some nested division in here. And what I mean by nested division is we have two division problems all together right here. So I'm going to rewrite this. I only like to have one division problem at a time as far as fraction form. So I'm just going to rewrite my first one exactly how I have it. Kilograms times meters per second squared. Now, remember our fraction bar is a division symbol. So instead of putting this over kg again, our kilograms again, I'm going to use our other division symbol, the one that you guys are more used to seeing from middle school and elementary school, and I'm going to divide by kg, or kilograms. This is the same thing. This is just a different way and a cleaner way to write our nested division up here. Now everything else is going to stay the same. We're still going to be equal to a. Now what this is going to let me do is manipulate this a little bit further. If you remember from when we were doing dividing by fractions in middle school, you had a little trick called keep, change, flip, where you keep the first term exactly the same. So we're going to just write kilograms times meters over seconds squared. You change the sign to multiplication and you flip the fraction. Now kilograms, if we wrote as a fraction, just like if we wrote 3 as a fraction, it would be 3 over 1. We're going to write kilograms over 1. And when we flip that, that becomes 1 over a kilogram. Now this is going to lead back into our unit analysis type thing. Remember when we had the same unit on top and the same unit on bottom, we could cancel out. So we can cancel out this kilogram and this kilogram. Alright, our formula is still going to be equal to a. Alright, But now that we've canceled out those kilograms, we can simplify this a little bit further. Just like when we did unit analysis, we're going to multiply the top and multiply the bottom. Alright, so on the top here, we're just left with a meter, and we're multiplying by 1. Anything times 1 is going to be a meter. So I'm going to go ahead and keep my meter on top. And on bottom now, I have seconds squared times the 1 kilogram that we canceled. So I'm just going to have seconds squared. Now, this is still equal to A. Alright, now, we have meters on top and seconds squared on bottom. None of these are the same unit, so we're not going to be able to cancel anything else out. So we are actually at our final answer. And we're going to see that the unit for acceleration is meters over seconds squared. The other way that you might see this written sometimes is meters per second squared. Either way is correct. Alright, that's two ways to write the same thing. Alright, that wraps up this example. This is probably the more difficult one from this application, so if you guys can hang in and follow through on this one, you should be fine on the rest of the application. As always, if you have any questions, don't hesitate to let us know. We're here to help you out. I know literal equations can be a little bit tough. It's one of the tougher lessons from this unit, but I believe in you guys and know that you guys can do this. Alright, have a great night. See you in the next video.